Hi everyone, I would like to explain about STAAD PRO G+2 building. The details are the plan, the centerline plan of the building and the elevation of this building details, analysis and design of G+2 building using STAAD PRO. This is connected edition. This is the new version. Previous version is V8i version or SS6 version. This is the updated version STAAD Pro. STAAD means structural analysis and design program. Okay, this is the latest version. In latest version, we have the recent codes in this version like IS 875 Part 3 2015, that is wind loads, that the recent revised year codes are updated in this connected edition. The given details, the grade of concrete is M30 grade we use in for applying this building. Grade of steel Fe 500. Clear cover for beams and columns is 25 and 40 mm respectively. Height of each floor. Floor to floor height is 3.2 meters. Depth of foundation. This is the depth of foundation from plinth level to ground level is 1.5 meter. The slab thickness is 125 mm. This is the slab thickness. This is the panel of slab. Okay, very small. I just take a small example of this building and explain uh, how we can analyze and design of G+2 building using this edition, new version, STAAD connected edition. Okay, and the details. We used this code booked for load calculations is IS 875 Part 1 1987 dead loads, that is the unit weight of materials and store materials. IS 875 Part 2 1987 imposed loads, and the IS 875 Part 3 2015 wind loads. IS 1893 Part 1 2016 earthquake load for buildings. These are the codes we used in this today video. Okay, is a small plan, the structural beam layout, the centerline plan. Is the x direction we have two base, z direction also we have two base, and bay distance also given in this plan. Okay, in this line diagram. Okay, this is the center line diagram. Okay, I will continue with the software. Now I will start with STAAD Pro. This is a continue. This is the STAAD Pro Connect Edition. Start with new project, and we give one name like some MDD, that is the name is MDD. This is a capital letter MDD. Just any name. I take MDD. This is the metric and the create. This is the interface of the new version. Yes, this is the new Connect Edition Plus. We have interface like this. This is the black surface model space or graphical area. We have design in this area. This is the some input value, some icons like this. This is the menu bar, and these are the menu bar, and this is the process. We have 5 steps in this any type of STAAD Pro. First one is the modeling. Second one is the support condition. In modeling, the properties also we have to given properties like the cross sections of the beam and the column dimensions like that. And the second step is the support, fixed support, pin support like that. Third step is the load calculations, that is the loads and definitions. Uh, in this dead load, live load, earthquake, wind load, these are the types of loads we have given in this third step. and the fourth step is the analysis, and the fifth step is the design. These are the 5 steps in any type, like in STAAD Pro or ETAPS. We use these 5 steps to complete the analysis and design. Okay, I start with modeling. When I start modeling, we have create one node. Okay, there is the empty space. We have no nodes. Then we have to create the coordinate system method. We have different types of methods used to create modeling. One is one first method is the coordinate system method. Second method is the copy paste method. Third is the grid method. Different types of methods we have, but this is, first we have to create one node. That's why I use this coordinate system method. First, 0 comma 0 comma 0. Okay, I use origin point 0, enter. This is the one node created. Now using these nodes I can do modeling easily. Right click, we use this select cursor. We select node means node cursor. We use node cursor, select node cursor, and drag this red icon highlighted in red color is selected node. Okay, uh, this selected this node, and control C control V is the copy paste method. What is the diagram we have? Please check the AutoCAD plan. This is the x direction, this is the z direction, and the y direction is the height. Okay, in x direction 4 and 3, we copy this node from 0 to 4. Next to this point to this point, we have to copy like that. Okay, first 4 4. Okay, okay, this is the isometric view. That's why this view is like this. I use in view, these the views. This is isometric view, this is the top view, this is the front view. Okay, in plan we use top view, and this node I select this node and control C and control V. Again this dialog box will come, and the distance is 3. Okay, this horizontal we created nodes. Then add beam. In geometry, add beam is there to connect these nodes from one point to another point, and this point to this point. Okay, we create 2 beams. Okay, as per plan, this I create this line, this continuous beams, 2 beams. Okay, now I create from z direction. It is easy. Z direction, select 2 beams, control C control V. In in z direction, now z direction, how much distance? 4 and 3. 4 from this point to this point, 4 distance. Now select this point, control C control V. Again z direction, 3 meters. Okay, now create these points. Now add beam. Now select add beam and join this point to this point, this point to this point, from this point to this point, this point to this point, and again. Okay, select. This is the total model I create as per this center line diagram. Okay, now in elevation, this is the I create this plinth beams. Now we have to create columns. Now I use the view is isometric view, and this is the nodes when the columns are in the same node direction. Okay, exact node position. Now again right click, select cursor, node cursor. How many columns? Totally 9 columns. Control A for all nodes. Okay, we have to select only for some selected nodes, means we select this and control, hold control, then we have to select, then only the nodes are selected. Okay, in this diagram I have selected all the nodes. Okay, select all the nodes and then translation repeat I use. In the translation in geometry, in select, this is the node cursors. This is the, in geometry the translation repeat option is there. In this use translation repeat y direction. In the grid the y is the upper side. Okay, I use the vertical distances means y direction. Number of steps is 1 and the spacing is minus 1.1. Negative indicates the downward direction from this point to down position. Okay, I use the foundation depth, that's why I use minus 1.5, link step and OK. This is the columns I created. Now I have to create multi-stored G+2 building. This is the G+2 building. I already given analysis and design of G+2 building using STAAD PRO connected edition. Okay, G+2 building means these three floors, totally three floors. Again, I use the view and select front view and escape. Escape means this is the cursor. Which type of cursor it is this this is node cursor. Okay, I use beam cursor, then right click and select cursor, beam cursor or escape button. Escape button means this is the defaultly we the cursor is the beam cursor. Okay, select, drag this like this and check in isometric view all the beams are selected or not. Okay, then use geometry, translation repeat, y direction. Now number of steps is 3, that is g plus 2. G plus 2 means ground floor plus 2 floors, that is the total 3 floors. Each spacing of floor is 3.2 meters as given in the AutoCAD plan. 3.2 meters. I use 3.2 and the link step and OK. Okay, the total modeling is completed. Now in the modeling we have other point, that is the property. We select property. In this, these are the total steps are in this bar. Okay, use continue from one step to another step, we have to continue this like this. Now the step is the property bar, property and the define. We use define and these are the different cross sections of the different properties: rectangular, circular, other different trapezoidal, different shapes we have. In column we use rectangular, beams also use rectangular. Okay, the minimum size of the column is the first. I have given the beam distance, beam dimensions, that is the beam width. Width is the, this is the width, this is the width and this is the depth of the beam. Width means ZD. We use ZD 0.3, wide, sorry, ZD is the 0.23, YD is 0.3. Okay, this is the minimum dimensions. Add next column means 0.3 by 0.3. Okay, once I check 0.3 YD ZD is 0.23, change. Okay, next 0.3 by 0.3 for columns. Okay, I again change this one, that's why the property again change it to this 0.3 by 0.3, change. Okay, now close and again define and rectangle. Now I have given the values are 0.3 by 0.3. This for column dimensions, and this one beam dimension. These are the minimum dimensions. We have to first check the minimum dimensions, then after the beam or column, when the beam and columns are failed, then we have to change the properties. Okay, now we have taken the small the minimum dimensions of the beam and column. These are the beam dimensions, these are the column dimensions. Okay, first assign these beam dimensions. Beam dimensions means select beam parallel to x and beam parallel to z. Okay, all beams are selected. This is the beam property. Assign to selected beams. Assign s. I assign this beams. We have to check this, right click and 3D rendering. The beams are assigned correctly. Okay, now we have to select the columns. Columns means again parallel to y. The columns are selected. Again parallel to y. The columns dimension, the column property we selected, then beam parallel to y. Okay, all vertical columns are selected. Now assign to selected beams. Assign s. All the columns also selected. We have to check the 3D rendering. All the model, the property is assigned. Now this is the first step we have completed. Second step is supports. Support is very easy. Create and the fixed support. All the multi-stored buildings or any type of RCC framed structures, we use a fixed support. Add, select support and view, use front view, where the supports we have in this footing. Okay, select these all these three. No, use node cursor and select all these three and assign to selected nodes. Assign s. Okay, in please check in 3D view also. Then okay, all the column nodes are selected, all the footings are selected. Okay, fix. Second step was completed. Now third step is loading. In loading, in this video I would like to share with only dead loads and live loads, not included earthquake and wind loads. Okay, I just explained for understanding purpose in this video. Okay, I select load case details and add. In this load case, different types of loads. One is dead load. The name we have changed, dead load. Dead load. Next add. Next again take live load. This is live load. Again add, close. These are the two details we added. In dead load, again select dead load and add. These are the different loading conditions, loads. Okay, the self weight of the dead load, the factor is -1, that is add -1. Next, member load. Member load is nothing but the wall load. Okay, member load units is the kilonewton per meter. Okay, this is the calculation of wall loads. These are the deadly imposed loads. Okay, calculation of wall loads, that is equal to external wall and internal wall. We have three types of walls in this plan. I will show in plan, in AutoCAD plan. This is AutoCAD. Okay, these points are the external walls. Okay, these are the external walls, and the inside walls are the inner walls. Okay, and the parapet wall is the superstructure wall. This is the parapet wall. These beams, the beams, this is the parapet, that is the terrace floor. Okay, this is the second floor roof beam. In the above we laid parapet walls. Okay, assigned external wall, internal wall, and parapet wall. That is the load calculations for the three types of walls are: calculation of wall load equal to external wall equal to 230 mm thick wall. Generally we use external wall is 230 mm thick wall. In inches means 9-inch wall. Okay, the calculation is unit weight of brick into floor to floor height minus depth of the beam into thickness of wall. Then the units are kilonewton per in terms of kilonewton per meter. Okay, the unit weight of brick is 19 kilonewton per meter cube, and the height of floor is 3.2 meter from floor to floor height. In that, the depth of the beam we deduct that depth of the beam. The depth of the beam is 300 mm, that is 0.3 meter, and the thickness of wall is 0.23 in meters. 230 means 0.23 meter. 19 into some, this multiplication of these three values is equal to 12.68 kilonewton per meter. The calculation of wall inner wall is same procedure, but the thickness is changed 0.115, that is 4.5 inch wall. And the calculation of wall load for parapet wall is 0.23 thick wall. I assume 0.23 meters. 0.23 meters. This is, that is 230 mm. Okay, 0.23 meters thick wall. Unit weight of brick is 19. Parapet height means ettagoda 1 meter. That is the thickness of wall is 0. The 0.23. The value is 4.37 kilonewton per meter. Kilonewton per meter means that is the UDL load. Okay, uniformly distributed load. Okay, these values I have given in this member load. First one is minus 12.68. Minus indicates downward direction. Is the vertical upward direction, is the positive, y direction is upward, but the gravity loads, dead load is the gravity load, live load is also gravity load, these act downward direction. That's why I have taken negative direction, negative value. Okay, minus 12.68. This is the outer wall. Add next minus, again the value is 6.34, minus 6.34. Again add, the last value is minus 4.37. Okay, minus 4.37. Please observe why I have taken negative value. That means negative indicates the downward, minus y direction, that is the downward direction. The gravitative load acting on negative y direction, that is the downward direction. Okay, add, the three values are added, the three UDLs are added. Next, in the dead load, the pressure load, that is the floor load also is there. That is the floor load. This is the floor load means that is the pressure load, that is kilonewton per meter square. How much value? The calculations of floor load calculations, the pressure load equal to unit weight of RCC into thickness of slab. Unit weight of RCC means 25 kilonewton per meter cube into thickness of slab given in this question. The slab thickness equal to 125 mm. This is the slab thickness is 125 mm, that is in meters 0.125, that equal to 3.125. Floor finish 1.5. Floor finish is nothing but the tiles or marble, anything, that is the, that is also the dead load, that equal to 1.5 kilonewton per meter square. The total dead load is 4.625. Now I have given minus 4.625. 4.625. Okay, the y range is the minimum value. Minimum means origin point to maximum means how much total height of the building. 3.2, 3.2, 6.4, 6.4, 3, 9.6. Total height of the building is 9.6. I given the maximum value is 10. Okay, the maximum up to 10 meters, the loads are automatically taken, the dead loads. Okay, now add and close. The total loadings, we insert the total loadings based on manual calculations. Now live load also we have taken. Okay, live load is also floor load. Live load we have taken from code book, that is, I will show the code book. This is the code book part 2, IS 875 part 2 1987. This is the code book for code of practice for design loads other than earthquake for buildings and structures. Part 2, imposed loads. This is the imposed loads code book. In this, in architectural plan we know the building type and building usage, like residential building or institutional building or assembly building or any public building, whatever may be. We know the which type of building we have planned, we have designed, we know based on architectural plan. Okay, for example, we have taken residential building means, in this code, the residential type of building classification also given. For example, we see this one, occupancy or usage group. We have different types of buildings, that is assembly building and marriage assembly buildings and business buildings, office buildings, educational buildings, different types of buildings. We have storage buildings, we already discussed in classes. Okay, different types of classification of buildings, we have different residential, like that. Total all type of buildings, totally in this code they have given. In table 1, imposed floor loads for different occupants for live load calculations. Okay, this is a imposed load means live loads. Okay, residential building. In residential building, dwelling houses. Okay, dwelling houses, hotels, hostels, boarding houses, different lodges, different types. In that also, under dwelling house, that is the individual house, all rooms and kitchen, how much live load we have taken. Toilet and washrooms, how much live loads we have taken. And corridors and passages is the common area, staircase, including all the escapes. These we have taken 3 kilonewton per meter square. This is the units. Okay, we have taken and we have given input in live loads. Okay, in residential building generally we have taken minus 2 kilonewtons. Now I have taken in live load, in floor loads we have taken minus 2 value. The maximum Y range is 10 meters. Now add and close. We have taken all the loads from under dead load and live loads. The input values we given in STAAD Pro. Now we assign these values to this structure. Okay, first one is the outer wall, inner wall, that is the parapet wall, like that. Okay, this is the outer wall. Now in view, we select front view, and outer wall means this is the parapet face. This is the topmost of the building. Okay, we use load condition, that is a parapet loading. Okay, exclude this one. That's why I select all these beams and right click in this new view. This is the new view. Okay, now only what I am selected, that only visible in this total in this interface. Okay, remaining all the unselected elements or members are hide. Okay, now I use isometric view. I use top view, no top view. This is the external walls. I select this one using beam cursor, and control, hold control, press control, and select all these external walls. Okay, these are the beams in the walls, total walls, or rest on the beams only. That's why we select these beams. Now in that loads, select this one, and we check in isometric view also. Okay, now this select this one, assign to selected beams, assign. Yes, I assigned total outer wall. Now inner wall means, again we select inner walls using control button. Okay, these are the inner walls of this building. Again I check in isometric view. Okay, all the internal walls are selected. Now I use this one. I use this one and assign to selected beams, assign yes. Okay, now I assigned both outer wall and inner wall, that is external wall and internal wall. When we assign, the symbol is changed like this. Okay, unassigned symbol is like this. We have to compare these symbols. Okay, next, now parapet wall, we the parapet total, we that is hidden. Now what we have to do means, in views, we select isometric view, and this whole structure button we select. Then the total whole structure again visible. Hidden elements or hidden members also visible. Now again front view, use front view, and selected the top floor. Next again right click, new view. Okay, only this top floor, terrace floor only visible. Now easily use top view, where the parapet wall rest on beams, only outer side. Again press control and select outer face, outer beams. Okay, outer beams. Next select this one and assign to selected beams, assign S. I selected all the three walls. Now this one already assigned. Whole structure again, all the loads are assigned. This floor load and the live load floor load also directly assigned. No no other options, we did not use any other options. Okay, in live load also automatically assigned from ground 0 to up to 10 meters. Okay, This is only 9.6 meters, but we have taken 10 meters maximum value. Okay. Next, these are the different dead loads and live loads. Then we have add another one, that is the combinations. In practically any loads like dead load or live load are only based on the combinations. Okay, dead load is the self weight of the material or self weight of the structure. Live load is nothing but the movable objects like furniture, man, okay, people or anything. These are the live loads. Okay, now factor means in as per IS 456 2000, the factor load is the combination of factor load is dead load plus live load. We use 1.5 factor and a dead load, live load, and add and close. This is the one combination we use. Generally, we have taken first earthquake loads, next wind loads, next dead load, live load. Based on the different combinations as per code we have given. After that, all the combination we have to check the results based on the maximum moments or maximum analysis results. We have design based on that combination. Okay, we already know that one. Now, almost third step was completed. Now, fourth step, that is the analysis. In analysis, different define command in that no print, add, close. Okay, this one is enough. Analysis, no print, add. Now check the run analysis. Is the run analysis, select. Okay, no errors and no warnings. That is, the modeling was correct and the loads are correct to we have assigned. Okay, go to post processing. Okay, and select this one and select all these points. Okay, all these points and apply and okay. Okay, these are the analysis results. Okay, related to displacements, displacements like that, and the beam results, in the beam results, and graphs. Okay, these are the graphs. We select this beam. This is the bending moment diagram. This is the shear force diagram of this beam, and the column. This is the bending moment and shear force of this column. Okay, what we selected of the beam and column, it gives the bending moment graphs and shear force graphs. And another one is beam stresses, beam nodes, and another one beam forces. We select this one. These are the maximum bending moment and the maximum shear force values. Okay, total values we have. We select this one. The total members are selected. We just copy and paste in Excel sheet. We have to sort out the results manually. Okay, these are the one type of process. Okay, uh, we have bending moment diagrams and shear force diagrams, all the displacement values and the reaction values, the footing reactions also, totally in this is the summarized values of the reaction values. Okay, we just select and select, just click in this button node, then select all the total points. Okay, then we take copy and paste in Excel sheet, and we have to calculate for reactions for footing design. We use footing design for this reaction based. Based on these reactions, we have designed footing. Okay, these are the analysis. Now design means, again click this one and the design, and in which design, this is concrete design. We select this concrete, then the code will appear, that is IS 456. Next, define properties. Clear means which type of, for beams, for beams, 0.025, that is 25 means in converted into meters. Add, and for column 0.04, add, this is the clear cover, clear. Next, FC value. FC means compressive strength of concrete, that is the value M30 grade, that is 30,000 value, because 30 Newton per mm square, but in this unit kilonewton per meter square. That's why we converted into mm square to meter square, kilonewton per mm square to kilonewton per meter square. Then the value is 30,000. Add. Next, Fy. FC was completed. Fy main. Fy main is, in this question, the value is given. Fi value, that is the grade of steel, Fe 500, grade of concrete M30. Okay, that is 5 lakhs. Okay, is also converted 500 Newton per mm square to meter square. We have converted, that is 5 lakhs kilonewton per meter square. Add. This is enough. Fe secondary, optional we have given or not, that is 415 or mild steel. That is secondary reinforcement, the like stirrups, and the maximum and minimum values of the steel bar. In the design part, the minimum grade of, the minimum diameter of bar used for beams and columns is 12 mm bar. The maximum within the limit is, we have select maximum 25 mm bar only, not greater than 25 mm. We did not select, we don't know, we don't exceeding 25 mm bars for this design means we select the maximum bar for design. Okay, these are optional, and okay, I am not added this one, and the close. Now commands: design of beam, add; design of column, add; and the take off, add and close. We all add all this, we assign all this to structure. Then the design part was complete. The design part is complete. Next, first one, clear cover. Clear cover for beams 25 mm. Now what we have to do? Select beam parallel to X and beam parallel to Z. Okay, for beams 25 mm clear cover, assign to selected beams, assign as. Again, second one, beam parallel to Y. For columns, column clear cover, assign to selected beams, assign as. Columns also completed. Next, this one is the grade of concrete and grade of steel for whole structure. That's why select and assign to view. Okay, use assign to view means total whole structure will select. Total whole structure is selected. Okay, total structure was selected now. Then Fy, that is 500 Newton per mm square steel bar. That is the tensile strength value. Fe 500. Assign to view, assign as. Please observe this point. This is assigned, this assign. Assign means tick mark. It shows tick mark. Unassigned means like this. It shows like a bulb. Okay. Next, design of beam. Again, beam parallel to X and beam parallel to Z. Okay. Design of beam. Sorry. Assign to beam parallel to x and beam parallel to x and beam parallel to z. Assign design of beam, assign to selected beams. From selected beams only we selected some beams. Next, assign to y direction parallel to y. Assign this design of column, assign to selected beams, assign s. After this one, all total selected, then analyze, define commands, no print again. We select no print for perform analysis, then run analysis and OK. Okay, go to out processing. There is no errors and warnings. Go to out processing. Okay. Okay, these are the different analysis of movement reactions like that. In this STAAD Pro, this is the basic level of STAAD Pro I thought in this video, but actually reality we have added earthquake loads, wind loads like that based on the depend upon the zone and the wind intensity based. We have added the location based. We have added wind loads and earthquake loads, and the different combinations also we added, like real actual combinations is 42, like factor load combination and service load combinations. These are the different combinations also we added in this load calculations. And another one is uh, in a wind based on the wind code book. We refer code book based on that. The input also we have given, and the earthquake also in four directions, and wind also four directions. Earthquake and wind are the lateral load calculations, that is the lateral horizontal loads, but the dead load and live loads are the vertical loads, that is the gravity loads. Okay, dead load and live load are the gravity loads, wind load and earthquake are the lateral loads. Okay. We added these loads and combinations, and in some part secondary beams also added in some cases, based on in secondary beam. When we add secondary beams, we can release the movements in this end positions, that is the one point. And cracked sections, as per code, cracked section values also we added, and the slave values also we added, and the orientation of the columns also we have changes, and the renumbering also we have changes. Renumbering, that is the beam numbering. For example, this beam has one numbering. Okay, like another one, this beam also a numbering, beam numbering, and the node has one numbering, like that. Node has one number and beam has one number. This is the orderly we have placed. The option is the renumbering. That the renumbering helps to easily identify the beams. For example, we use 100, 1000 value, 1001, 1002, 1003. That is the plinth beam. Uh, for example, 2000 means first floor, 3000 means second floor, 4000 means terrace roof. Like that, we have given some numberings. That is the renumbering. Uh, and cracked sections, renumbering, and the slave values. Okay, that is the diaphragm. Other one is the diaphragm. That is the diaphragm means slaves, master slave. In STAAD Pro, we have given all these and analyze. Then only the structure, analyze and design is perfect. Okay, in STAAD Pro generally we use for steel structures, and non-high-rise buildings we use STAAD Pro, but high-rise buildings can use ETABS. That is the better and preferable software for high-rise buildings. Non-high-rise buildings means 18 meters or below height of buildings, we use STAAD Pro. and steel structures. In STAAD Pro use steel structures analyzing is very perfectly and precisely they given the STAAD Pro gave the results. Okay, that is the better one. STAAD Pro user for steel structures is very beneficial, and non-high-rise buildings also is very beneficial. In STAAD Pro, the static analysis and dynamic analysis also we given for non-high-rise buildings. Static analysis we use code IS 1893-2016 part 1 for buildings. There is earthquake resistant design code. Static method is the at rest position method, and the dynamic is the response spectrum method. In that dynamic analysis response spectrum is very important method. Uh, all these we use these methods and we analyze the structure. Then only the results were taken. In STAAD Pro, we design only for beams and columns. Based on the reactions, manually we have designed the footing and the manually we designed slab design also using Excel sheets. Okay, we use spreadsheets and design for slabs and footing. Only STAAD gave these results for beams and columns. Okay, this is the RCC structure. Okay, we click double click means the concrete design. It shows the concrete design, the top reinforcement, bottom reinforcement, like that, and the column also. Concrete design means this is the column reinforcement of column size. Based on column size, the STAAD gave these results. Okay, if we click double click, the concrete design is not shown means the column will fail. Column or beam it failed means it not show any concrete design. Okay, this is the very important point, and all the results we check in this right side dialog box, and based on the analysis we can do manually results, manually design or STAAD design. Okay, generally we take an area of steel only based on STAAD results. In I will show another one. In utility, the command bar is there, input command file. Okay, I just click in utilities. In older version the menu bar view, in view also this option is there, input command file. We click that input command file, the total program run on this input command file. What are the loads we are given, the total shown in this input file. Okay, for example floor load, what I given wiring 0 to 10 meter, minimum value, maximum value. Floor load means minus 4.625 I have given. Okay, live load I have given, dead load I have given, member loads. What I have given in input file, the total loads I have shown in this command file. Okay, we control A for select all, control C, copy, and I use one text document and paste it and save it, control S. Okay, this is when I use this file, this control A and copy and paste it on this input command file, then the structure again will again came whatever structure, whatever type of structure, we just replace this one. It shows the total structure. After the run analysis only we have to copy this one and paste in text document. Okay, Without run analysis, the results are changed. Okay, save. Okay, save. Next, another one is in this another point also there. That one is a man file. Okay, after this closer one. Okay, total loads. We have changing these loads in this place also. For example, I have changes this -2 to -3, -2 to -3. This is the live load, floor load. That is a pressure load. I have given as per code -2 value, but I have changed in this input command file -3, and close and save as. Okay, now close, then analyze. Check in loading in live load, double click the value. Okay, value is not changed actually. I will see again. Command file is not going. Okay, based on that we have changed means after saving, we checked run again, we select run analysis and check the results. Okay, thank you. After this video, I will plan for total whole structure from starting to ending point. I will make different videos on this for easy purpose, for easy learning purpose. I take one architectural plan and the structural plan, and total loads, different types of loads, different combinations. Okay, total from starting to ending, the whole designing. I will make one video or different videos, different series videos. Okay, please like this video. If you are like this video, uh, I will do more videos. And comment also, please give comment for any corrections or any mistakes. Please give one comment. Okay, thank you.